Yeah.
Okay.
Okay.
Perfect. Thanks.
We're good now?
Mhm.
All right.
I'll just be out here if you have any other issues. Just let us know.
All right. Good afternoon, everyone. My name is John Crighton, and I'm delighted to be here today to explore the dynamic world of cloud computing with you. I'm currently the CTO at Capital Add-ons, and for the past 6 years, I've been using cloud infrastructure exclusively. Prior to that, I managed teams that used both on-premise computing and hybrid computing before moving exclusively to the cloud. As the Chief Technology Officer that works with a lot of different clients and computing models, I have a lot of exposure to cloud technology and the rapid advances that are happening there. Cloud computing comes in several different flavors, including private clouds and hybrid clouds, but public clouds provided by third-party vendors like Amazon Web Services and Microsoft Azure and Google Cloud are the focus of software organizations, and so that's what we're going to talk about today. Now, why is it crucial to stay ahead of the future trends in cloud computing? The answer lies in the rapid pace of technological evolution. Cloud computing is not static, it's continually advancing. Emerging technologies and trends shape how we use cloud resources and influence the competitive landscape for businesses. Understanding these trends helps organizations to make informed decisions about their IT strategies, optimize their cloud investments, and leverage new innovations to drive growth and efficiency. As we move through today's discussion, we'll dive deeper into these trends, including advancements in artificial intelligence and machine learning, the rise of edge computing, and the benefits of containerization, and security challenges that are continually evolving. By understanding these developments, you'll be better equipped to navigate the evolving cloud landscape and harness its full potential. As we delve into the rapidly evolving landscape, we'll focus on two key areas: the integration of artificial intelligence and machine learning, the rise of edge computing. By understanding these trends, we position ourselves to not only adapt, but to lead in this dynamic field. Let's start with artificial intelligence and machine learning, technologies that have moved from being experimental to essential components of modern cloud infrastructures. Cloud platforms use AI to process vast amounts of data with unprecedented speed and accuracy. Machine learning algorithms automate routine cloud management tasks, such as resource management and system monitoring. This automation reduces operational costs and minimizes human error, making cloud environments more efficient. AI-driven predictive analytics help organizations anticipate future needs and trends. For instance, cloud services can predict peak usage times and automatically scale resources to meet demand, ensuring performance and cost efficiency. Consider the healthcare sector, where cloud-based AI systems analyze medical images to detect diseases at early stages, or the retail industry, where machine learning algorithms optimize supply chains and improve the customer's experiences. These applications demonstrate how AI and ML are not just transforming cloud computing, but becoming integral to innovation across various domains. Moving on to edge computing, an innovation that's gaining momentum due to its potential to reshape how we handle data. Edge computing involves processing data closer to where it's generated, rather than relying solely on centralized cloud data centers. This approach reduces latency and bandwidth usage, which is crucial for applications requiring real-time processing. Here are some of the key benefits. By processing data at the edge, we minimize the delay between data generation and action, which is vital for applications like autonomous vehicles and industrial automation. Edge computing alleviates the strain on network bandwidth by processing data locally. This efficiency reduces the need for large-scale data transfers and to centralized cloud servers. Local data processing can also enhance security by reducing the exposure of sensitive data transmitted over networks. Additionally, edge devices can be equipped with robust security measures to protect against local threats. Edge computing complements cloud services by providing a hybrid approach. While cloud remains central for large-scale data storage and complex computation, edge computing handles real-time data processing and analytics. This synergy provides a more responsive and adaptable IT infrastructure. As we navigate the future of cloud computing, staying abreast of emerging technologies is crucial. AI and ML are enhancing our capabilities and efficiencies, and edge computing is revolutionizing data processing. Understanding these trends equips us to leverage their potential effectively, anticipate challenges, and innovate continuously. Embracing these advancements not only prepares us for the future, but prepares us to be at the forefront of technological evolution. Now we'll explore two transformative areas that are reshaping how we design, deploy, and manage applications: serverless architecture and containerization, particularly with Kubernetes. Serverless computing allows developers to build and run applications without managing infrastructure. Instead of provisioning and managing servers, you simply deploy your code, and the cloud provider handles the execution, scaling, and infrastructure management. This shift allows you to focus on writing code and delivering value rather than dealing with the complexities of server management. Recent improvements have significantly enhanced the performance of serverless platforms. Cloud providers are optimizing cold start times, which is the delay experienced when a function is invoked after being idle. Newer execution environments and better caching mechanisms are reducing these delays, making serverless computing more suitable for latency-sensitive applications. Serverless platforms are now supporting a broader range of programming languages and runtimes. This flexibility allows developers to use tools and languages they're most comfortable with, enhancing productivity and easing integration with existing codebases. Modern serverless platforms provide more robust integration with other cloud services and APIs. Enhanced event-driven architectures allow for seamless integrations between serverless functions and the various data sources or messaging systems, facilitating complex workflows and real-time processing. Serverless computing continues to evolve in terms of cost efficiency. Recent advancements have introduced finer granularity in billing and better cost management tools, making serverless more economical for various workloads. Serverless architectures are providing invaluable access across domains. For example, serverless is an ideal fit for the microservices architectures, where each microservice can be deployed as a separate function. This modular approach simplifies scaling and maintenance. Applications that rely on real-time data processing, such as chatbots or real-time analytics, also benefit from serverless capabilities. These applications can process events as they occur, providing timely insights and responses. Now we'll turn to containerization. Containerization involves encapsulating an application and its dependencies into a container, which can then be consistently deployed across different environments. This technology simplifies deployment, scaling, and management of applications. Container orchestration platforms, particularly Kubernetes, have seen significant advancements. Kubernetes, an open source platform originally developed by Google, automates the deployment, scaling, and management of containerized applications. New features and updates enhance its capabilities, such as better support for multi-cloud and hybrid environments, and advanced security features. As containerization becomes more prevalent, security has become a major focus. Recent developments include enhanced security features like runtime security monitoring, vulnerability scanning, and improved isolation mechanisms to protect against potential threats. Containerization platforms have improved in their ability to develop and scale applications rapidly. Features like rolling updates, automated scaling, and self-healing capabilities ensure that applications remain available and responsive even under varying loads. Kubernetes has refined its declarative configuration model, allowing users to define the desired state of applications and infrastructure in configuration files. This approach simplifies management and ensures consistency across environments. Containerization supports continuous integration, continuous deployment, or CI/CD pipelines by providing consistent environments from development to production. Kubernetes automates the deployment process, ensuring that upgrades are smooth and reliable. Organizations are using Kubernetes to manage applications across multiple cloud platforms. Its portability and flexibility make it an ideal choice for multi-cloud and hybrid cloud strategies. Kubernetes is increasingly used for managing large-scale processing tasks. Its scalability and resource management capabilities are crucial for handling big data and machine learning workloads. Now I'd like to discuss an increasingly critical aspect of cloud computing, security. Specifically, we'll focus on the latest advances in cloud security technologies and the implementation of the zero trust models. As cloud adoption accelerates, understanding and implementing robust security measures becomes essential for protecting data and maintaining trust. Advancements in threat detection and response technologies are significantly improving cloud security. Modern cloud platforms utilize advanced machine learning and AI to identify and respond to security threats in real time. These technologies analyze vast amounts of data to detect anomalies and potential threats more accurately than traditional methods. These tools can automatically detect suspicious activities and patterns that may indicate a security breach, such as unusual login attempts or data access patterns. This automation reduces the time between detection and response, minimizing the impact of security incidents. Encryption remains a cornerstone of cloud security, and recent advances are making it more robust and adaptable. End-to-end encryption ensures that data is encrypted from the moment it leaves the client device until it reaches the destination. This approach prevents unauthorized access during data transmission and storage, providing a higher level of security. Security as a service solutions and managed security services provide comprehensive security monitoring, threat detection, and incident response. These services are typically offered by specialized security providers and allow organizations to benefit from expert knowledge and advanced technologies without the overhead of managing security operations in-house. Cloud security posture management tools help organizations maintain and manage their cloud security posture by continuously assessing configurations and compliance. These tools provide visibility into potential vulnerabilities and misconfigurations, helping organizations to proactively address security risks. Moving on to zero trust. The zero trust security model is based on the principle of never trust, always verify. Unlike traditional security models that rely on perimeter defense, zero trust assumes that threats could be internal as well as external, and that trust should not be granted based on network location alone. Instead, every access request is verified and authenticated regardless of its origin. In a zero trust model, users and applications are granted the minimum level of access necessary to perform functions. This principle reduces the potential impact of a security breach by limiting access to sensitive data and systems. Microsegmentation is often used as part of a zero trust model and involves dividing the network into smaller, isolated segments in order to limit the spread of potential threats. By applying security controls at the network segmentation level, organizations can contain and maintain security threats more effectively. As we navigate through the evolving landscape of cloud computing, enhanced security measures are critical to protecting our digital assets. Advances in cloud security technologies such as AI-driven threat detection, improved encryption techniques, and security as a service solutions are helping organizations to stay ahead of emerging threats. Meanwhile, the zero trust model provides a comprehensive approach to securing access and reducing risk by verifying and validating every request. These improvements allow us to safeguard a cloud environment and ensure the integrity of our data and applications. As we continue our journey through the realm of cloud computing, we turn our attention to a critical aspect that often dictates the success of cloud adoption: cloud economics. Specifically, we'll delve into cloud optimization strategies and the intricacies of pay-as-you-go versus subscription pricing models. One of the fundamental strategies for cost optimization is right-sizing resources. This involves matching your cloud resources, such as compute instances, storage, and networking, to the actual needs of your workloads. The first step is to utilize a cloud cost management tools to monitor your usage patterns. These tools provide insights into resource utilization and identify areas where you may be over-provisioned or underutilized. Based on your analysis, you adjust your resource allocation to better fit your needs. For example, if you have a compute instance that's consistently underutilized, consider downsizing to a smaller instance in order to reduce costs. Autoscaling automatically adjusts your cloud resources based on current demand, ensuring you only pay for what you use. Implement autoscaling across various services, including compute, storage, and databases. This comprehensive approach helps manage costs across your entire cloud infrastructure. Set up autoscaling policies that automatically increase or decrease resources based on predefined metrics such as CPU utilization or request volume. Let's talk about the differences between various types of payment models. Pay-as-you-go or pay-G is the default pricing model that all cloud providers use, and it's the pricing model where you pay for your cloud resources based on actual usage. This offers several benefits. It provides flexibility to scale resources up or down as needed. There's no need to commit to long-term contracts. This feature is beneficial for short-term projects or startups with uncertain future needs. Choosing between pay-G and subscription models depends on your specific needs and usage patterns. For dynamic workloads with variable demand, pay-G offers greater flexibility and cost control. For steady workloads with predictable usage, subscription models can provide cost savings and budget predictability. Subscription-based pricing involves paying a fixed amount on a set period, either monthly or annually. These subscriptions usually come with discounts compared to pay-G pricing. Providers may offer lower rates for longer-term commitments, making this model cost-effective for predictable workloads. Some subscription models require committing to specific resource levels. This can be beneficial if you have consistent performance capacity, but may lack the flexibility of pay-as-you-go. Reserved instances and savings plans offer significant cost and savings compared to on-demand pricing. You purchase reserved instances for predictable workloads. By committing to a specific instance type and region for a 1 to 3 year term, you can achieve substantial discounts compared to on-demand pricing. Cloud providers also offer savings plans that provide flexible pricing options in exchange for committing to a certain amount of usage over a period. These plans can be more flexible than reserved instances, allowing you to apply discounts across various types of services. Conduct regular cost audits to ensure that your cloud spending aligns with your budget and operational goals. Reviewing detailed billing and reports to identify unexpected charges or trends in your spending. Many cloud providers offer tools to help you analyze and understand your billing data. Establish budgets for different teams or projects and set up alerts to notify you when spending approaches or exceeds these budgets. This proactive approach helps to control costs and avoid surprises. Navigating cloud economics requires a strategic approach to cost optimization and an understanding of pricing models. By implementing cost optimization strategies such as right-sizing resources, auto-scaling, and leveraging reserved instances, you can maximize the value of your cloud investments. Understanding differences between these subscription models allows you to select pricing structure that best aligns with your organizational needs and financial goals. From emerging technologies and innovations to security measures, the economic considerations, our discussion today has illustrated the dynamic and multifaceted nature of cloud computing. Cloud computing is not just about technological advancements, it's about integrating these innovations in a way that enhances efficiency, security, and sustainability. The future of cloud computing lies in our ability to harness emerging technologies, optimize costs, and adopt greener practices while ensuring robust security. As you move forward, consider how these insights can be applied to your projects and strategies, embrace opportunities that cloud computing presents, while remaining mindful of the challenges responsibilities that come with it. Thank you.